I will turn off my webcam because it's better. So I need to just open my door. Okay, just a second. Okay, so this is very easy to understand. R is a position vector. So this position vector have X coordinate and Y coordinate. So just write these coordinates in T, in time, in a time equation. This is the parametric equation, okay? Just like that. So let's do the question 2. Determine the position vector in time t equals 2 seconds, okay? Do you know what you need to do in this question?
We need to substitute t with
Yeah.
2.
Yeah, perfect. Just substitute 2 in the t in this equation, just like that. So can you do this for me? When you get the answer, just tell me, okay?
Yep.
Okay, thanks. If you have any doubt, just tell me too.
X is equal to 12 and Y is equal to 8.
Perfect. Just put the number where the question say to you put. It is very easy. Let's to the question 3. Calculate the absolute value, the position vector in the instant, the before instant, before instant. Okay. So what is the instant? Is the t equals 2? But he wants to know the absolute value. Okay, absolute value. The absolute value, you need to understand graphically what is this. For example, if you have a vector, it's like a line, okay? But this line have coordinates. Sometimes we don't have the necessity to know the coordinates, the position, just the absolute value, the range, okay? The range of this vector. But to know the range of this vector, you need the coordinates. So what's the coordinates you get in this question? Can you tell to me again, please? The coordinates are x equals
12 and Y equals 8.
8, okay. So if you draw this vector in a xy plane, you have something like that. You have 12 and 8, okay? And you have this, a vector. But if you put these lines, you can saw, in some sense, a triangle, okay? Because this line is equal here. So you have a triangle, okay? This triangle have the coordinates 12 and 8. So you can do the Pythagoras theorem, okay? Do you remember the Pythagoras theorem? Something like hypotenuse square equals one side square plus on the other side square. Do you remember this equation?
Yeah. Yeah.
Oh, okay. Pythagoras theorem. We use all the time in math and physics. So when you listen Teorema de Pitágoras is the Pythagoras theorem, okay? In this situation, this is
Yeah.
the hypotenuse. This is the hypotenuse. The absolute value of this vector is the hypotenuse, okay?
Yeah.
So just put the numbers, 12 square plus 8 square, and do this count. Can you do this for me? You can use your calculator, okay? So when you do this for me, just tell me the answer, okay?
It's equal to 208.
How much, sorry?
208.
But you do the square root? Or you just sum? Did you
No, I
just
don't.
sum? You need
I
to do
don't,
the square root, okay?
the
Is
square root is
144 plus 64, okay? So, I don't know, 8, 0, 2, so 208, right?
yeah.
So now you can use your calculator to do this square root, okay? Do you know what you need to do?
Yeah. Square root.
Okay.
So it equals 4 square root 13.
Sorry?
It equals 4 square root 13.
Ah, okay. So you factorize this number, or your
Yeah.
calculator do this kind of count. Okay.
It was 30, not it was 13, not 13. 30.
Ah, 13. 13. Okay. Sorry.
Yeah.
My English is bad, man. But you is a cool guy, so you understand me. Okay, please. Thanks. Um, Let me see the next one. Determine the equation of the path and write and draw graphically in the time interval 0 to 2. Okay, so you need do the graph. Okay, you need to do the graph of this situation. But this situation have a problem because you have a two-dimensional move. Okay, you have move in the x plane and x axis and y axis too. So it's interesting if you understand the two equations at the same time. But I think it's more interesting if you put some numbers in the equation to have more points to put in the graph, okay, in your draw. So, for example, you do this, and we can put the 0 too, because the question speak about 0, but it's interesting put the number 1, for example, in T 2, because it's the number between 0 and 2, okay? So our graph will be more beautiful, okay? More understandable.
Yeah.
Okay, so we can put 0, 1, and 2. let me see. We can take this equation and 0 and 2. Okay. I will write here. So let's put the numbers. I will write here 0. I will copy this and put the numbers. I will put the 0. You will put the 1, okay?
Yeah.
So now we have -4 to x and 0 to y. Our first point is -4, 0. Now you can, you need put 1. You need put 1 in this equation. So when you have the answer, just tell me, okay? You don't need to be fast. Just you need to be right, okay? Use the time you need to do this.
So in the first one, I'm going to use time equals 0.
No, in the first one, you need to put time equals 1.
Okay.
So just put the number 1 in the letter T, okay? Ooh. Sorry, man. I think I closed something, but I will return. Okay. You just need take this. You just need take this equation in the letter T. You put the number 1 and do the calculate like me here. Okay. But T equals 1 in this situation.
So x will be 4 and y will be 4.
Perfect. Exactly. X is 4 and y is 4 too. So we have these points. We have the first point. We have this point too. And we have the point you calculate in another situation. Here. Okay. In this situation, we have the point when the time is 2. We have the point 12 and 8. All right. So I will write this here. And we have 3 points to draw our graph, okay? I will draw the XY plane first, but I will draw, I think this XY plane is enough to me. in this moment, at this moment. Okay. The cool thing in physics is we never have negative time. So we can just have concerns the positive side of the XY plan, okay? But when we are working in which time here, but in this situation, we don't have exactly the time here. We have the X letter because we have these situations here, these points, and our graph is a X and Y graph, not a X and T graph, not a position and time graph. Okay, position versus time graph. We have a X versus Y graph. Okay, so you need to have this careful. You need to be careful about this, about why, what you will put in the graph. Here we will put the xy. Okay, so here is y, here is x, and here is the points. -4, 0. This will be the head point. -4, 0. -4 for x. So here, -4 for x, and y for y is 0. So here is the point, because here is the 0. For example, I will put it for more close of the xy plan. You will see y soon. So, for example, in the xy plan, here is y, so here 12. We can put here 4, and in this situation, this cross, we have 0. 0 for the x and 0 for the y. So this here, we can put our point. This point, I will put purple. Okay. I don't know why I changed the color, but okay. So we have here 4 and here 12. Okay, this is our first point. Now we can put this point, 4, 4, 4 to x, 4 to y. So how can I put this here? I just do this point line in 4 and another point line in 4, 2. The cross is where you put the point, okay? Any problem? Do you understand?
Yeah.
Okay, amazing. So now we have another point, 8 to y. 8 is here, for example, to y. 12 is here, to x. This will be the red. So we have this. So this is the move, okay? You can see this move is a straight line, okay? Determine the trajectory equation and represent graphically in the time interval. Now we have the draw of this graph, okay? I really don't understand what the question say about determine the path equation, because we have two path equations. We have this and the parametric form too. So we have a lot of equations. We don't need another one, okay? So I don't understand what the question is asking in this moment. at this moment, okay? So I just draw the graph. In another moment, I can think about this question, but I don't know what is speaking here, okay?
Yeah.
Another moment, we do this too. But okay, any doubt? Do you have any doubt?
No, I understand.
Oh, okay, amazing. Let me see the another one. The another one is little similar. Little similar the first one. Just a second. Okay. This is a question of the national exam. So this is a really important question. Okay. And they will use similar questions to um, to the another national exams too. The questions is very similar year by year. So you really need now know how to do this question because it will be important to your future. Ok.
Yeah.
Muito bem. Ok, well. A particle of mass m move in horizon xy plane by the move law. Okay, this is the law. This is the equation of this particle. Which the affirmations, which the answers is right? What is right here? Not this, or this. We can read this. The path is a line. The path is a line. How we can um, know this? How we can discover this? How we can search this? We just look this equation, and we can do the polynomial structure of this equation. This equation have a square. Did you see a square? So when we have a square, we have a quadratic equation. Okay? I don't know if you know, but a quadratic equation is have a graph like this. Do you understand?
Yeah, I
Okay.
understand.
This is like x squared equals y. So this is not a line. Do you agree with me? This is
Yeah.
a parable. So
Yeah.
this is wrong because the particle, the path of this particle is not a line. Okay. Uh, I will I will state this here, and let's go to the B, question B. The normal component, the normal vector of acceleration is null. Then the normal, the component normal of the acceleration is null. So we have a position equation, but he is asking about acceleration equation. So do you know how um, get a acceleration equation of this equation? How can I get acceleration equation? Do you know? Do you have some idea? Do Do you remember something?
Acceleration formula.
Yeah.
I took it, but I don't remember it.
Do you don't remember? Okay. So you need use the derivatives. Do you already study the derivatives?
No,
Derivation? No,
I
not yet. Not yet. But you really need the derivatives here. I suppose. I I use this, but I don't know if you really need. I need think just a second to me. I need to think something. Okay, just a second. Just a second. If you don't study derivatives yet, I think we have another path to understand this equation, this problem. Okay, but I need to think 1 second about it because you saw the situation, the graph, but actually the move is in a horizon situation, in a plan. Okay, um, but we can use the derivatives. I don't know, just a sec, because the normal component of the acceleration. Just a sec. I think it is. Oh, the situation is you have a component x, just a component x. Why? Because this have a move in a plan. The move of this particle is in a plan. In a plan, okay? So we don't have a component of this move, and why? This question is a little strange again. This is very strange. But when we think about the acceleration in y plan, we can solve this is zero because the structure of this equation, but I just know this because the derivatives, okay? We really need the derivatives to understand this equation. So it's a really strange if you don't study derivatives yet, because I will teach you. It's easy, okay? But
Yeah,
you need to speak with your teacher because this situation you really need the derivatives. So we
yeah.
are
I was told that I need the derivatives.
uh, so do you know how derive this equation? Do you know? I think you don't know.
Yeah, I don't know.
No problem. So, for example, this is a vector. So, to be more easy, you can rewrite this equation like this: t minus 1 squared t minus 1. And you can do this math. You can do this math. If you do this, we have t squared minus 2 plus t more 1 plus 1. Okay, 2 times t plus 1. Okay, I just do this math, do this multiplication. Okay, and here we don't do anything because it's right. Now we can derivative this. We can derivate this just now. You need one law, one rule to do this derivative is a really easy rule. So if you have a function, your function is something like x to the power of n, for example, n is a number, okay? The derivative is n times x to the power of n minus 1, okay? N times x to the power of n minus 1. So for our situation, for example, here we have t squared. We can do this derivative t squared. Our n is 2, okay? Our n is the letter 2, is the number 2, okay? So when you do the derivative, the 2 goes down, and you have t to the power of 2 minus 1. 2 minus 1 is 1. So we have t to the power of 1. But when we have 1 in the exponential, né, we don't need to write this. It's just 2 times t, okay? We have another law too, another situation too. For example, here, we have this situation, minus 2 times t, okay? What is the derivative of minus 2 times t? Minus 2 stay here, okay? They stay in the position, minus 2. But you really need derivate this in this t, this letter. So what is derivative of t? If you think a little, we have 1 here. So 1 is the n. This 1 goes down, and you have it t 1 minus 1. This is a really special situation because minus 2 times 1 is minus 2. So now we have 0 to the power of, in the power of t. And you remember, anything to the power of 0 is equals 1. So we have just minus 2 plus 1, or minus 2. Okay? Do you understand?
Yeah.
Very easy. And here we have plus 1. This is a function too. You can do all the things at the same time, but how I am teach you, I am do this step by step, okay? So what is the derivative of a number? Any number, 0, is ever 0, okay? So we have the derivative of r. The derivative of r is the velocity. The derivative of the position is the velocity. And the derivative of the velocity is the acceleration, okay? So what is our derivative, our velocity? 2 times t, here minus 2, and 0. So 2 times t minus 2 in x position. In the y position, what's the y position? Just, you need just derivative these two things too. So what's the derivative of t? Just 1. And the derivative of minus 1 is 0. So we have just 1. This is the position. Okay? Just like that.
Yeah.
And to the acceleration is the derivative of velocity. So what is the derivative of 2t minus 2? Again, you just use that rule here, and we have 2 because we just need derivative the letter t. And the derivative of -2 is 0, so we don't need put 0 here because it's ugly. But here you need, because you need show we don't have acceleration in the y coordinates, okay? Here yet is x and y, but the xy here velocity in x and velocity in y, and here acceleration in x and acceleration in y, okay? So we have the equation. So we can see something really interesting. This 0 is the acceleration in y coordinate. When you saw this figure, this object, this particle, don't have acceleration to in the y coordinates. We don't have, because it's 0. So this particle will not have a normal, because if you study physics, you know this is the normal component, okay? The normal component is the force, the basis of where your particle is. So this is the normal component, okay? Normal is perpendicular to your basis, okay? The normal component in this situation is the y, is the y-axis. So if the problem asks you about normal acceleration, in other words, is the question is about y acceleration, okay? But we do, so we do the math, and you saw the value of this acceleration is 0, okay? And the problem speak about it. The normal component of acceleration is 0. So this is correct. This is correct. The first one is wrong, and the letter B is correct. Okay?
Yeah.
Very good. Do you have any doubt about this?
No.
No? Okay. Very good. So we can do the letter C. The sum of the forces in this particle is constant. The sum of the forces in this particle is constant. To understand this question, first you need to understand the Newton's second law, okay? But I don't have more space in this board, so I need open another. Just a second, okay? I will copy this, and I will save this board to send to you. Now I will paste here, and and we can go on. So you really need to understand this Newton's second law. The Newton's second law say the sum of the forces, the resultant force is mass times acceleration, okay? So if you have acceleration that depends of time, it means your force is time dependent too, okay? So we need saw the acceleration you obtain in the another question, okay? Let me see the acceleration in the another question. If you saw the acceleration in another, if you see with me here, the acceleration in another question, we have 2 about acceleration in x and 0 about in acceleration and y. Okay, so these 2 values don't depends of time. It's not time dependent. It's constant. It's ever 2 for x and ever 0 for y. Right?
Yeah.
Do you understand? So this is so we can conclude. In this situation we don't have variation of the forces, because the force is a thing who depends of the acceleration. For example, this situation, the force in x is the mass times the x acceleration, and y the same thing, but in y acceleration. But we have 2x acceleration 2 and y acceleration 0. So 2m and 0. But 2m will never change. This will never change. Never will change, because the mass is ever the same. The mass never change. And here is 0. Here we don't have force at all. Okay? So we can conclude the force is constant, is ever constant, never change, because it's not time dependent. To change, the force need be time dependent, but is not. Okay? Do you understand?
Yeah.
Okay, amazing. So this is wrong too. This is right. This is wrong. This is wrong too. Let me see the D. The velocity component in x-axis is constant. The velocity component in x-axis is constant. We need to store the velocity equation in the another thing, the another board. I will send the board now to you. You can saw this in your WhatsApp too. But I will put it here. Just a second. We have the equation here. The equation is here. So let me see the equation. Oh, you can see the velocity and x. This component is x. Do you remember? Oh, okay. X. This component is time dependent. We have the letter t, time. So if the time pass, your velocity will change. Okay. Let's read again the letter t. The velocity component in y-axis is constant. What do you think about it? It's right or it's wrong? Is constant the velocity in x-axis? Is constant or not constant?
Velocity.
Yeah, the velocity is constant or not? No? Yeah, amazing, man. You are right. It's not constant because the letter T. Just for it. Just because the letter T. Okay? Amazing. So it's not constant, so this is wrong too. Wrong too. The tangential component of the acceleration is constant. The tangent component is the component of the move, just like it. The move, how it is. How can I say this? For example, you have this. This is our particle. Okay, we know, we saw in the equation, this particle have acceleration in this component, But we don't have in y. We don't have a y component of acceleration. We don't have. Because we saw here. Okay, we saw here. We have a component in y, but this component is constant, is ever 2. This is very normal in physics. Normally, our component, our accelerations components is or 0 or a constant number. It's never is time dependent. Acceleration normally is not time dependent. Okay, so we have 2. We have in axis component 2. Axis component is the tangential component. Okay, is the same thing. Tangential and x component is the same thing. Normal component is ever y component. Okay, so you can remember this. Ever is ever the same thing. Okay, so we have a x component. We can see this here too. Is constant, like the question said to us. Okay, so this question is right. This affirmation is right. Okay, it's constant because it's true. If you were 0, it's constant true. But if you would have, if you would have a letter T in this situation, is not constant. Okay, you just need search for the T's. If you have T, it's not constant. If you don't have T, it's constant. Okay, just like that. So you understand, we can solve the next question to us today. Just a second. We have another situation similar to this. If you have any question, just tell me, okay? Do you have some question?
No.
Okay, you're very smart. This is cool. I was living in Braga 1 week ago. I lived near of University of Minho. Do you know University of
Yeah.
Minho?
Yeah,
It's close
I
to
know.
you? It's close to you?
It's maybe like 30 minutes away by walk.
It is really close. Amazing. You are the first student I have of Braga. I lived there, but I don't have any students of the city until now. This is amazing. So let me see this equation. This unidimensional move of a particle have this rule. Okay, this is the rule of this movement. Calculate the velocity of particle in the instant t equals 2. You know how to do this. Can you do this for me?
Substituting the t.
Perfect. So when you have the answer, just tell me, okay?
Okay. Equals +4.
Or yeah, 4 exactly. But you need pick the unity too. 4 meters, okay? 4 meters.
Yep.
How can I know if it's meters? Because this SE international system, okay? In international system, the path unit, the length unit is meter, okay? So you are right, for meter. 2. Determine for the interval 0 to 4 the mean velocity and mean acceleration. Okay. You need to know the equation of the mean velocity and mean acceleration. But it's an easy equation, okay? It's very easy. Mean velocity is the, how can I say this? Just a second. Displacement. Displacement divided by time. Okay, just like that. Displacement divided by time. So you need to know how much you walk in 4 seconds. Okay, you need to know how you walk in 4 seconds, but you need to know also how much where they stay in the t equals 0 to. So we need to put here s instant t equals 4 minus s, the displacement, the position, in t equals 0 to. So here we can put 4 minus 0, okay? But what you need to do now? You need to put 4 in this equation to know this, okay? But if you put 4 here, you saw this math will be 0, okay?
Yeah.
4 minus 4, 0. 0 squared, 0, 2. So if you, now you have, you need to put 0. 0 in the place of t, okay? If you put 0 here, you have minus 4 to the power of 2. So how much is minus 4 to the power of 2?
It's 16.
16, perfect. So now you have you pay attention, be careful, because we have this sign, minus sign, this is here. But you say to me, this is 16. So you can put 16 here. But pay attention, because this number sometimes is negative too. So you have this sign game, like minus with minus is plus, and plus with minus is minus. So you have pay attention with the signs, okay? And under we have 4. So to finish our class, minus 16 divided by 4 is minus 4. Minus 4 what? Minus 4 meters by seconds, okay? This is the unit of the velocity. So the mean velocity of this situation is just minus 4 meters by seconds, okay?
Yeah.
Man, amazing class. You really do everything I asked to you. This is really important, really cool. So if you want more classes, just tell me, tell for your mom too. So I will be here to help you, okay?
Okay.
Okay, man. Good luck. Until the next time. Bye-bye.
Thank you. Bye.
Thank you, bye.